Okay, what we're going to do is we're going to estimate the capital asset pricing model here. You have the CAPM is equal to this formula here. The expected return of any asset I is equal to the risk-free rate plus beta. That's our measure of systematic risk, or you can think of that as the firm's exposure to systematic risk. And then what we're going to use to measure the systematic risk is the expected return on the market minus the risk-free rate. Now think about what that means. So uh, let's talk about the coronavirus for a second, right? So this pandemic that's happening right now is a systematic risk event. It's going to affect all the entire market, right? So we've looked at this graph before here, and you can see that it doesn't matter how many assets we put into our portfolio, we're unable to diversify away all of that risk, that systematic risk, or what we call market risk. This pandemic is a perfect example of a systematic risk event. And beta is measuring the exposure to that systematic risk event. How do we approximate that risk event? We just take the expected return on the market minus the risk-free rate. So think about this. The pandemic has had an adverse effect on markets. In fact, it was reported yesterday that the 30% decline in the stock market has occurred in the last 22 days. All right? That is the fastest 30% decline in stock market history in the United States. Okay? So we're going to use how stock prices, how the stock market's prices change as our measure of systematic risk. I hope that makes sense. We don't know how to measure the pandemic's risk, but we know how investors are going to respond to that risk, and that's what we're using to measure the systematic risk event. Beta is measuring the firm I's exposure to that systematic risk event. Okay, so we're going to estimate this thing in practice. This isn't it isn't too difficult to do, but watch what I'm going to do here. So what I'm going to do, I'm going to use regression analysis. I'm going to subtract the risk-free rate from both sides, and when I do, I get this formula here. Okay, so what that means is I'm going to go about estimating this regression. Okay. The y variable, or on the y-axis, the dependent variable is going to be, I'm going to use historical returns for each firm I, and I'm going to subtract that risk-free rate. Right? So look at what I've done here. Because I've subtracted the risk-free rate from both sides, now I'm going to use historical returns for firm I minus the risk-free rate. That is my dependent variable. Okay. And my independent variable, give me 1 second here. My independent variable is going to be historical market returns minus the risk-free rate. This is the market risk premium, or this is our measure of systematic risk. So I'm going to grab some historical data points. I'm going to plot those data points in the y-x domain, okay? And then I'm going to fit a line that minimizes the squared difference between each of these data points to that line. All right? The slope of this line will equal our beta. And notice that alpha should equal 0. We're going to come back and talk about the significance of alpha equaling 0. When I subtracted the risk-free rate from both sides, I mechanically forced alpha to equal 0. All right, when I'm estimating this thing. Okay, so this alpha is going to have some meaning. We'll come back to that in a second, but what we want to do here is we want to estimate betas. Let's go ahead and do this. So I've pulled some data here. All right, so I've got monthly data for the last 5 years. I have January 2015, February 2015, and so on, all the way down to December 2019. So I got 5 years of data. I've got monthly data for Microsoft, Facebook, Google, Apple, Walmart, Amazon, Netflix, and Tesla. Okay, so I've grabbed historical data for 8 stocks. I've also grabbed the risk-free rate. The way that we approximate the risk-free rate is we take the short-term yield, or the yield on short-term government bonds. T-bills is what they're called. Okay, so this is the yield on 3-month government bonds. All right, And then I have two measures of market returns. This is the valuated market return. Let me explain what this is here in a second. This is the S&P 500 market return. You probably know what that is. Okay. The valuated market return differs a little bit from the S&P 500 market return because the valuated market return consists of all publicly traded stocks that trade on all of the major stock exchanges in the United States. The S&P 500 only includes the 500 stocks. So we're going to estimate the CAPM using two different measures of market returns for a few of these stocks, all right? And we're going to show how sensitive our measure of beta, our systematic risk measure, how sensitive beta is to the assumptions that we make when we include market returns, the different types of market returns. Okay, so look, you're going to actually have to do this in the project, in Project 5. So I'm only going to do Microsoft and Facebook. Okay, I'm going to estimate the CAPM for Microsoft and Facebook. You're going to have to estimate the CAPM for all 8 stocks in the upcoming project for this week. And so let's go ahead and do this for Microsoft and Facebook. Pay attention. This will help you on the project. The first thing that I got to do is I've got to create the dependent variable for Microsoft. Okay, so recall that my dependent variable is equal to the historical market return. The historical return for each stock, in this case Microsoft, minus the risk-free rate. So I'm going to say equals Microsoft's return during the month, January. Actually, careful here. I'm going to scroll up to the top, make this a little easier. Say equals Microsoft's return in January 2015 minus the risk-free rate. I'll highlight that or drag that down. So this gives me the return for firm I, which is Microsoft, minus the risk-free rate, and my independent variable, my Y variable, my X variable for Microsoft. Actually, it's going to be the same for everyone, is going to be equal to, let's start with the evaluated market return minus the risk-free rate. Okay. In fact, let me do this. Let me just call this the independent variable, and then in parentheses I'm going to put valuated market return, and let me make another column in column Q. Call this the independent variable where I use the S&P. Okay. This will be useful, I think. We're going to estimate this for both the valuated market returns and the S&P 500 market returns. In the project, I'm only going to have you estimate it using the value returns, and you'll see why here in just a second. So the independent variable using the S&P 500, I'm going to take the S&P 500 return minus the risk-free rate. Drag that down. All right. So here we're estimating this for Microsoft. We've got the market risk premium using the valuated market return. That includes all stocks that are publicly traded on the major stock exchanges. Or we have the market risk premium using the S&P 500 return. To run the regression, you guys should be comfortable doing this by now. We've done this in multiple projects here. I'm going to click on Data Analysis. Again, this is under the Data tab, under the Data Analysis tool. I'm going to highlight Regression, say OK. All right. Let me go back and show you. This is the Y range, so this is the dependent variable. Okay, my dependent variable is going to be the difference between Microsoft's monthly return. Hold on just a second here. Okay. And my independent variable, let's start with, sorry about that. Let's start with the evaluated return here. Okay. All right, so I've got Column O is my dependent variable. Column P is my independent variable. Let me go ahead and estimate that. Look at what we have here. So for Microsoft, I get an alpha of 0.0145. That's 1.45%. A t-stat of 2.26. Those who understand statistics know that anything that's above a 2 in absolute values, I'm pretty confident that that thing is different than 0. And then look at my beta. Okay, my beta is 1.14. The t-stat is 6.29. So beta is fairly close to 1. All right. And hopefully you understand that a beta greater than 1 means that this particular stock has more exposure to systematic risk than the entire market. A beta less than 1 has less systematic risk exposure than the entire market. Of course, the market portfolio, if I were to regress the market, the beta on the market is just going to be 1. All right. Let's look at some stuff here. This will be useful. I'm going to go to CNBC. Let me also go to Yahoo Finance. And if I pull in Microsoft and view some of the information on Microsoft, let's see how close we are to estimating the same beta that that CNBC has. Look. So CNBC estimates beta, and they say the beta for Microsoft is 0.94. Okay, so this is kind of interesting. Beta's 0.94, slightly less than the market. If I go to Yahoo Finance here, let me pull in Microsoft. Of course, that's not Microsoft. Hold on. I get a beta of 1.09. So notice I'm all over the place here, right? So my estimate using the valuated market return, is 1.14. CNBC's estimate is 0.94. Yahoo's estimate is 1.0 something, 1.09 or something, 1.09. And so I'm all over the place a little bit. I think that's important to understand that it depends on what you're using. So Yahoo Finance, it says uses 5 years of monthly data, which is what I use. I'm assuming it uses the same risk-free rate. The difference is probably the market return. Let's go and see. So what I'm going to do now is I'm going to, instead of using the valuated market return for Microsoft, I'm going to use the S&P 500. Let me run the regression here again. Again, my dependent variable is column O. And my independent variable here, instead of the valuated market return minus the risk-free rate, it's going to be the S&P 500 return minus the risk-free rate. Okay. Hit OK. And look at this. If I use the S&P 500 return, I get 1.23% or 1.23 on my beta. My alpha is similar, but slightly different. My beta is 1.23. Let me compare that with the previous. Again, alpha is similar. My beta was 1.14 using the valuated market return. So this is important. I think this is a useful attempt to estimate beta and show that the estimates for beta that you get on Yahoo Finance or on CNBC or on any other website, right? Fidelity will report betas. Those betas are estimated using statistics, and the statistics are obtained, and the results are obtained using different assumptions. Okay, I'm not exactly sure. We could probably figure it out by Googling the answer, what CNBC uses to estimate their beta and what Yahoo Finance use to estimate their beta. But I think this is a pretty useful exercise here.